Hi everybody, and in this video, what I want to do is I want to just continue our discussion about transformation parameters. And the parameter that I want to introduce is the k value. So for instance, y equals sine kx and y equals cos kx, all right? Now we talked already about the a, the d, and the c, but remember what we're talking about now is the potential of having this final parameter, which if you look at the big picture would look something like this. Okay, and then if you were talking about cos, it would be y equals a cos k x minus d plus c. So what does the k value do? Well, here's what it really does. We'll talk about k just in terms of being positive value, okay, because we're not going to do any examples where it's negative. So when I put k in absolute value symbol like that, that means I'm just talking about it in terms of positive. And k deals with horizontal stretch and compression. Now, just as a side note, if k were negative, it would reflect in the y-axis. We call that a horizontal reflection, but we don't need to worry about that in our course. Okay, we're just going to focus on the horizontal stretch and compression aspect of k. So what does that mean? Well, what it means is this: if the absolute value of k is greater than 1, then we get what's called a horizontal compression by a factor of 1 over k. So for instance, if you had y equals cos 3x, that would mean that your original cos function would be horizontally compressed by a factor of 1 over 3. Okay, and what does that mean? Well, that means something like this. If your original cos function looked like that, that's your parent function, it would now be 1/3 of that original length. So it might look something like that, okay? It would be severely squished in a sense, right? What else? Well, if the absolute value of k is greater than 0, but less than 1, then we have what's called a horizontal, I'll just shorten horizontal to the letter H, stretch by a factor of 1 over the absolute value of k. So once again, if k is between 0 and 1, we're talking absolute value now. So for instance, if it's something like 0.5, that means that we have a horizontal stretch by a factor of 1 over the absolute value of k. So if, let's just for argument's sake, say I had something like this, y equals sine 1/2 x, that means that my original sine function, my parent function, might look like that, but I have now horizontally transformed this function, horizontally stretched it by a factor of 1 over 1/2, which is meaning that I've horizontally stretched it by a factor of 2, because 1 over 1/2 is 2. Now what does that look like? Well, that means it's double the length. So that means that the graph will look something like this now. See that? We've horizontally stretched it by a factor of 2. Okay, this is a huge and very, very important idea then when it comes to these graphs, and you really, need to kind of absorb this idea. And I think that maybe the most important idea, which I haven't mentioned yet, just in terms of like quantifying or putting a number on what this does, is this very important fact, which I would encourage you to write down and remember, which is that the period of a sinusoidal graph, and that means in our case either the sine function or the cosine function, period of a sinusoidal graph shall be equal to 360 over k. 360 over k. The period of a sinusoidal graph shall equal 360 over k. What does that mean? Here's what it means. If I have a function such as y equals y equals sine 4x, that means that the period of my graph is equal to 360 over 4, which is 90. And that means, of course, that if we had our original parent function looking like that, the new parent function would complete a full cycle in just 90 degrees. Okay, so this is the K value and you need to know it. In the next video, I'll do an example where I deal with the K value on its own, and in the final video, I'll put together multiple transformations. Okay, thanks for watching.